Section 6.4 star is on page 455. This is identical to what we did, except it's going to tackle on the general logarithmic function and the general exponential function. So the natural log and the natural logarithm would be a log with a base of e and an exponential with a base of e. In this case, it's going to be a log with a base a and an exponential with a base a. So let's say I would like to take a to the x. Or even better, let me stick with the book notation. Let's go b to the x. It doesn't really matter. I want to take a derivative of this, but we have an issue. I don't know how to take a derivative of this. I know how to take a derivative of e to the x, but this I'm not sure about. So this is what I do. A nice trick. I'll say, if you take b to the x, that would be e to the natural log of b to the x. Do we see that? Those undo each other because that's a composition of a log and exponential with the same base. You're left with b to the x. And by the properties of logs, I could move this up front, and I could say this is e to the x times natural log of b. And keep in mind that natural log of b is a constant. So now, if I take a derivative of this, that would be the derivative of this. And that would be the derivative of this. And I know how to take a derivative of an exponential. Derivative of an exponential is the exponential times the derivative of the exponent. And since this is a linear equation, derivative of that is simply natural log of b. And if I untrack this, make that a power again, that is e to the natural log of b to the x times natural log of b, and those undo each other, and I'm left with b to the x natural log of b, which is what this is. And that's how you would take a derivative of e. You know what? I'm going to put all of that on a straight path. I normally don't like putting things that, but since this is matching, let me just put it all on one line so you can see how that works. So the derivative of b to the x is b to the x. It's kind of like derivative of e to the x is e to the x times natural log of b. And I could try to apply that rule of, what if I have y equal e to the x? If I take a derivative, according to this, it says it's going to be the exponential times natural log of the base. The base is an e. And isn't that a 1? So there it is. If I was to write this book, or I was thinking I should start with this first, then go to 6.3 and make that a special case. But we need all the practice we can get, and that's why I really kept on applying what the book does. So, if I take a derivative of b to the x, that's b to the x. Let me eliminate those. And now, let's see how this works. Derivative of b to the x is b to the x times natural log of b. So if I solve for b to the x, that is b to the x divided by natural log of b. So the derivative of b to the x over natural log of b equal is b to the x. And that means if I integrate the integral of b to the x dx, of course, that would be b to the x divided by natural log of b. And of course, don't forget, oops, not a circle. Of course, don't forget the plus c. There it is. So I know how to take a derivative, and I know how to take an antiderivative. Right? There's the derivative, and there's the antiderivative. Something I should keep in mind. And the rest is practice. First, they start off by saying they want us to really get this idea out. So they say, this is an expression. This is x to the raised to the radical x. Write the expression as a power of e. Well, this is e to the natural log of x to the square root of 5. Again, those undo each other because that's a composition of a log and exponential in which the bases match. And I could even go a step further and say that's radical 5 times natural log of x by moving this to the front, something that we need in a few sections, 6-8 to be specific. And if I get to the next problem, problem number 6, the same deal. Here, when I want to take a derivative of this, that's not simple. I'd say this is e to the tangent of x secant of x. Well, actually, I'm sorry, I forgot about the natural log. And that would become a coefficient. And I'll get to this when I get to the end of this section. There it is. Alright, and some practice with some logs. Now, I do have to warn you, I'm teaching Math 55 right now, and some of the students are struggling with these properties. And you know what happened when you struggle in 55 in these properties? Do you know what kind of help is available? Go back to your notes from 5B and review them. So make sure you get this. This is log base 10 of 10 to the 1/2. And in the log section, the natural log, I talked about the properties of those. If the base of the log and the base of the exponential match, they undo each other. Two logs with a minus in between, I could write as a single log of 320 divided by 5. Log base 8. 5 divides 32 6 times, and you have 20 left over, 4. And I could say that's the log base 8. Isn't that 8 squared? And the base of the log and the base of the exponential match, they undo each other, and you're left with a 2. This is two ways you could do this, and this comes up a lot. Either you say this is the log base a of 1 minus the log base a of a. Log base a of 1 is a 0. And since these match, they undo each other, you're left with a power, and you're left with a negative 1. Or you could say this is the log base a of a to the negative 1. And since those match, they undo each other, and you're left with a negative 1. And again, all of these problems come up, not only in this section, they really come up in Math 55 and Math 5C somewhat. Remember, a to the x times a to the y is a to the x plus y, and I'm going backwards. Of course, there are other ways of doing this. The base is a 10, the base of the log is a 10, they undo each other. The base is a 10, base of the log is a 10, they undo each other. And you're left with 28. Alright? So this is something you should really practice. I play with those a lot if I was you. And shift this up a bit. Change the base formula that was given on the last section. And that is actually natural log of pi divided by natural log of 2, or log base 10 of pi divided by log base 10 of 2. If I throw that in my calculator, there it is. Those are irrational numbers, extremely important for solving population, bacteria growth, decay, many other applications. When I want to find a limit, well, exponentials I'm an expert at because I took college algebra or pre-calculus, whichever. I look at the graph. Since the base is bigger than 1, this is exponential growth. The graph looks like that. When I take the limit as x approaches negative infinity, that would be 0, end of discussion. Here, if I throw the 3 in, I'll get a 9 minus 15 plus 6. That's the log of 0. That's not allowed. Well, I can't figure the problem as is, so what I do, I use my knowledge of factoring. Do you remember that stuff? That is x minus 3 and x minus 2. This is the limit as x approaches 3 from the right, log base 10 of x minus 3. plus the limit as x approaches 3 from the right of log base 10 of x minus 2. Throw the 3 in there. This is the log of 1. This is 0. This right here, I could look at the graph of log base 10 of x minus 3. Instead of the asymptote being at 0, it's shifted 3 units to the right. Let's say that's 3. And the graph is identical. Looks like, oops. It looks like this. And if I take the limit as x approaches 3 from the right, there's 3 from the right. That will approach a negative infinity. So if I take negative infinity plus 0, that limit is simply negative infinity. So make sure you show me this work when you're doing that. And now we get to calculus, which is kind of really straightforward for the most part here. It's identical to what we did. We just need to tag that extra natural log of the base. Differentiate, product rule. Derivative would be 1 times the sine of 2 to the x plus x times derivative of sine is the cosine of 2 to the x. Derivative of e to the x is e to the x. If the base is not an e, you simply multiply by natural log of the base, and there it is. A really straightforward process. Just don't forget that extra natural log of the base. And if I get to this problem number 30, if I take g prime, power rule, bring the power down, subtract 1 from the power, times the derivative of the inside. I'm writing this for your notes. You really don't have to write a 0. Derivative of an exponential is the exponential. Times natural log of the base. By the chain rule, the derivative of natural log of u is 1 over u. And there it is. If I want to take a derivative of a log, you notice I never mentioned a log, and let me elaborate on why that is. I'm going to go up here, back, I left some space out, and if I look at log of a general base, log base a of x, well, the reason I didn't touch on it because by the change of base formula, I could write that as natural log of x over natural log of a, and when you say what's dy dx, I'll say, well, look, that's a constant, you ignore that. And the derivative of natural log of x is 1 over x. And that's why I really didn't spend much time on it or explain how that works, because it's really straightforward in that sense. And if I take a derivative here, before I take a derivative, there are a couple of ways I could do this. I could say y equal natural log. Actually, I could expand that. I'll do that brute force and I'll do it both ways. I'll say that's log base 2 of x plus log base 2 of the log base 5 of x. So I could say dy dx without simplifying any further. I could say that's 1 over x times natural log of 2, if I memorize that, plus derivative of a log is 1 over the argument. Don't forget the natural log of 2, times the derivative of this, 1 over the argument, times natural log of the base. I could also say, you know what, let me take that, and derivative of a natural log is 1 over dy dx is 1 over the argument times natural log of 2 times derivative of the argument. That's the product rule. Derivative of the first times the second plus the first times derivative of log base 5 is 1 over x, 1 over the argument times natural log of 5. That's acceptable as well. And lastly, I could say y really equal natural log of x log base 5 of x over natural log of 2, y equal 1 over natural log of 2 times natural log of x plus natural log, and this is natural log of x over natural log of 5, no calculus there, y equal 1 over natural log of 2 times natural log of x plus, wouldn't that be natural log of x minus natural log of 5? And if I take y prime, that is 1 over natural log of 2 times 1 over x plus derivative of a natural log is 1 over natural log of x times the derivative of the inside. And this is, let me just make sure, yeah, this is a constant, that's a 0. You could write the answer in so many different ways. There it is. Now here, if you start simplifying, writing this as natural log of x over natural log of 5, this, and distribute, and you'll get the same answer. I'm going to stop this video here.